Hey, today we're going to be talking about applications of linear functions, and we're going to do some word problems, which everybody loves. Let's start with just a simple formula that we're familiar with. Distance equals rate times time. The distance d, traveled by an object, it's a function of how fast it's going times how long it goes at that speed. For example, if you're driving at 60 miles per hour and you drive for 2 hours, well, how far do you go? Well, your distance is your rate, which is 60 miles per hour, times your time, which is 2 hours, which is 120 miles. So if you're traveling at 60 miles per hour and you travel for 2 hours, you take the product between the two numbers to get your distance. All right, let's jump right into our application. This is a motorboat problem. So we got this boat going up a river, and it's going at some certain constant rate. If it was in still water, it would be traveling at some specific constant rate. Now, this is an unknown. We don't know what this rate is. Now, the motorboat heads upstream. It's going against a current that is 4 miles per hour. So think about as it goes upstream, it's losing that velocity. So whatever its constant velocity is, it loses 4 miles per hour as it goes upstream. Let's go ahead and draw a picture of this situation. So we've got our river, and this is upstream like this. Okay, so our current, so if I say upstream, I mean our current is flowing back this direction. And so it's slowing the boat down. So let me get a boat going. So anyway, so this boat is traveling upstream against a so this is a 4 mile per hour current. This is traveling at an unknown velocity. So we don't know what that is. That's actually what we're looking for. This is an important aspect of this question, is what is the speed of the motorboat? So we're just going to say unknown mile per hour against a stream that's going, a current that's going 4 miles per hour in that direction. Okay, now if there's more information here. The trip upstream took 5 hours. Now remember, we're going slower as we're going upstream. And so because we're fighting against the current. Now on the return trip, on the downstream trip, it only took 4 hours. Now in this case, we're gaining the 4 miles per hour. If we're going back down the river, that 4 miles per hour is added to our constant speed of our unknown miles per hour. So this is a kind of give and take. So what is the velocity of the boat? What is that constant speed that's unknown here for our algebraic equation? But before we do that, we should do a little trial and error first. So trial and error, what I'm saying is let's just guess at an answer and just see if it works or not. It will help us to understand the algebraic equations for this thing. So let's guess that the boat's speed is 30 miles per hour. Now, this may or may not be right. It could be that the boat is going really fast at 60 miles per hour. So but you just want to start somewhere. Just guess something and see if we can get the right answer. Now, be careful here. Now, what we want to do is compute the distance upstream given this velocity. Now, we know that the upstream trip took 5 hours. So the distance upstream would be the rate times the time, 5 hours. But what is the rate going upstream? Well, the boat's speed is 30 miles per hour. We don't mean that the boat's speed upstream is 30 miles per hour. You lose the current's miles per hour as you're going upstream. So you lose it, and then you gain it on the way back down. So kind of plus or minus the 4 miles per hour from the current. So that would take us to 26 miles per hour for the upstream trip. So 26 times 5, so 5, that's 130 miles. You want to pick numbers that are easy to compute. All right, now, so again, we're checking this possibility. Is the boat speed 30 miles per hour? So we need to look at the distance downstream. Now there's something kind of subtle here. The distance downstream should be equivalent to the distance upstream. And that's again, a little subtlety in this problem. But the downstream trip only took 4 hours. So 4 hours going downstream, but we gained 4 miles per hour. So it's actually 34 miles per hour. Now 34 times 4, that's 16 plus 120, that's 136 miles. And what this you got to interpret this. What this means, because they're not equal, this means this is not the speed of the boat, because the downstream must equal the upstream. So this is a little confusing there. I mean, what is going on here? So what we're saying is the downstream downstream trip, the distance down, should be the distance up. And this is a really subtle, I would call this the big leap. If you don't have this information, you can't get at what is the issue. So 30 miles per hour is not correct. If you tried it with 35 miles per hour, it actually does a little bit better. So if you did 35 and you add 4 and subtract 4, it gets pretty good. But let's go ahead and jump to our algebraic equations for the sake of time here. So the downstream trip, you're going to gain, so whatever the miles per hour is, we don't know what it is. I'm going to put an X here. The downstream trip has an unknown velocity, and we gain 4 miles per hour. But we know the downstream trip is going to take 4 hours. So you got your time, this is your rate, and this is your time. So rate times time. Your distance downstream is rate times time. Your constant velocity plus 4 is the velocity you gain. You gain some velocity as you're going downstream. This has got to be equivalent to the rate times time upstream. All right, now the rate upstream, so you're gonna lose the 4. It's gonna be x minus 4, and the time is 5 hours. All right, so these are hours. These are miles per hour. All our units are in good shape. We're ready to go. So this is our algebraic equation. And so now we just need to multiply and solve our equation. So you get 4x plus 16 has to equal 5x minus 20. We're going to get all your x's together. Let's bring the 5x over. That gets us a negative x on the left. Bring the 16 over there. Gets you negative 36. And there's our answer. X is 36 miles per hour. The boat would have to be going at a constant rate of 36 miles per hour in order for the distance upstream to equal the distance downstream. So this is the algebraic solution. Here's a little bit of trial and error, but I was using the trial and error to help us understand and compute the actual algebraic solution. Thank you for watching.